Hello, everybody. Today we're going to have a little talk about a question that seems pretty straightforward to me. Is psychology science? Now, before I go anywhere, I'm going to say the answer is hell yes. All right? So, keeping that thought in mind, in fact, how about I'll tell you this right up front. When I teach general psychology, the very first slide on the very first day says psychology is science. Psychology is so much more than Dr. Phil. All right? So I want you to know my opinion right up front. All right? Psych is science. Okay. So, question. Is psychology a science is somewhat controversial. There's a lot of people. In fact, here, let me tell you a little side story. Every university I've been at, the Department of Psychology has been in a slightly different college. I remember at my undergraduate school, it was in the College of Arts and Letters, okay? Which essentially is saying it's one of the humanities or something like that. I remember when I was in Missouri, it was in the College of Health and Human Services, so psychology is like a helping thing, right? Here at Texas Wesleyan, however, we're in the College of, what is it, NNSS, Natural and Social Sciences, which is something, okay? We're in the College of Science. But here's the deal: the hard sciences, so biology and chemistry. Why do we have to make a distinction between hard sciences and social sciences? Okay, and so we had to call it the College of what was it, Natural and Social Sciences, to make a distinction. Personally, I think it would have made a hell of a lot better letterhead if when the college was created, we just called it the College of Science. Okay, because let's face it, it is science. Now let's move on. Okay, first thing I wanted to I was going to say remind me because that's what I tell my students, but you know, you are my students, but you can't remind me. All right, I'm going to come back to this reaction paper one. Clearly, the material in here is relevant to every student in this class, whether you're going to write the first reaction paper or not. But I'll come back to this discussion after I've gotten through some more of this material. What is psychology? Well, historically, the study of psyche, right? The mind, the spirit, consciousness, behavior, whatever. I mean, we study a lot of different things, okay? Contemporary psychologists, you notice they study the biological correlates of mental events. Neither of these things are, well, mental events are things you can't measure per se, right? We'll get into the whole hypothetical construct thing at some point. Principles that govern learning and memory, unconscious motivation. In other words, we have a very, very broad spectrum of activity that we engage in. Okay, so let me move to the things that are interesting. Here's the deal, and in fact, in the last presentation, when I was talking about presentism, I talked about how quaint it was, this idea that way back when a caveman would think that thunder was the gods throwing rocks at each other or something like that. And I'm like, okay, you know what? Humans are explanatory creatures. They use whatever they've got available. And the thing is we are explanatory creatures. We want to explain things, and we do have a variety of tools in our toolbox. Now, these tools are, in fact, how about this? Taking a step back, we have multiple tools. So when we ask questions and we want to answer these questions, we have to find the appropriate tool for the job. Now, sometimes there's this conflict between religion and science, all right? You've seen it, religion and science, bang, bang, bang. But here's the problem, is that there are certain questions in this world that I should not be trying to use. If I try to use my science to explain, say, for example, what is the meaning of life, you've used the wrong tool for the job, and yes, you're going to come into conflict. If you want to answer a question such as, how does an internal combustion engine work, and you pull out your Bible, it's not going to work. Okay, granted, these are kind of extreme examples, but the majority of the time when religion and science butt heads, what happens is that you've asked a question and you grab the wrong tool to answer the job, okay? If you use the wrong tool. Now, science is a great way of learning about the world, but it is just one tool in your box, okay? And it is useful for many things, but not everything. Okay? So, what are the different ways that we know things about the world? Number one, religion. We know things about the world because the Bible tells it to us and we have faith. We know things about the world because we have used philosophy and we have philosophical beliefs about it. We know things about the world, method of authority, that is, somebody tells us about it. We know things about the world. Method of tenacity and a priori both make reference to the idea that we know things about the world because we're so stubborn we refuse to change our mind, essentially. They're not exactly ways to know about the world. They're not instinct. We know some things instinctively. But the scientific sources of knowledge, that is to say, one of the ways that we know about the world is because of science. That is to say, all scientific knowledge comes from empirical sources. It doesn't come from faith. It doesn't come from my pastor told me. It comes from I saw it. Okay? The beauty of scientific knowledge is that it is the only, on this whole list of knowledge here, it is the only one that is self-correcting. If you have mistaken beliefs that you have gained through religion, they're never going to be fixed. If you have mistaken beliefs that you have arisen through philosophical means, they'll never be fixed. If you have mistaken assumptions which have arisen through scientific sources, they will be fixed. Okay? Because the scientific method, by definition, is self-correcting. It fixes itself. That is a beautiful thing about it. We're going to talk more about these two philosophies, but very, very briefly, we're going to talk some philosophy, but it really comes down to there was two competing philosophical. We're gonna talk about a little bit of Plato, a little bit of Aristotle, where empiricism and rationalism came from and stuff, and we're gonna talk about Francis Bacon, who took these things and shoved them together. But back in about 1500, there was two major philosophies that were competing to be king of the hill: empiricism and rationalism. And I mean, they still exist to many degrees. Empiricism, in its most extreme form, says that all knowledge that you have comes from things that you've experienced in your lifetime. In other words, again, we're going to get the details on it, but in other words, you're born empty and you become the product of everything you experience. Rationalism, in its most extreme form, says true knowledge comes from at birth. At the moment you're born, you've already got true knowledge. Okay, and so empiricism is you got to see it to know it. Rationalism is you already know it and you find the answer inside yourself. Something like that. We'll talk more details later. Okay. Well, science blends together these two competing philosophies, okay? Because in the scientific method, we use empirical sources, that is to say, observation of data, okay? If this was a experimental class or something, I'd get into the whole, I'd show you the whole picture. But for now, suffice it to say that empiricism is, in the scientific method, empiricism comes in the fact that we take detailed observations. Rationalism is the idea that we generate theories. Generating theories means looking inside yourself to find the answer. So we look inside of ourselves to find the answer, and we generate a theory, which is a rationalistic way of working, and then we use those theories to create experiments which create empirically based data, okay, or observations, which are then used to test the theories, okay? So science is a blending of empiricism and rationalism. It takes the two biggest philosophies throughout the Middle Ages and puts them together into one belief system. It's a wonderful thing, okay? Science. Well, let me see. Science is a search for laws. As I said, humans are explanatory creatures. We want to explain the world, okay? And if you're a caveman and you hear thunder, you're going to explain the world using the only tool in your toolbox. Well, we now have science, and science's goal, in many ways, is to search for laws or better and better explanations. That's really what a law is an explanation. So a scientific law is a consistently observed relationship between classes of empirical events. In other words, things that are related to each other. Okay? And these laws are broken down into two flavors: correlational laws and causal laws. And again, it's a different class, but in an experimental class, man, this is a whole lecture right here, because correlational laws are beautiful. They allow us to predict things in the world. When A happens, B follows, okay? But experimentally based research allows us to establish the causal laws. If I make A happen, then B will happen, okay? So these are just different ways to understand the world, okay? Okay, hello, there it is. All right, I'm going to back up a little bit and say, in science, we do have some assumptions, okay? These are the assumptions that science makes before the scientific approach can really truly be accepted. We need to assume nature is lawful. That is, there are laws that describe events. Say the law of gravity. Okay. Now, many people have this problem, and they say, "Hey, yes, I understand that. Say, for example, if I drop my keys, I could drop my keys. There is a law of gravity to describe the speed at which the keys would fall and hit the earth. Okay, and when talking about my keys and discussing the speed at which they move and everything else, the idea of incorporating the word free will becomes silly when talking about my keys. Oh, my keys chose to fall to the center of the earth, and that is why. No, see, because free will doesn't make sense when talking about the hard sciences. I hope you're starting to see a reason why the hard sciences might disbelieve us, okay? Whereas in with a human being, you say, well, why did Mary do that? And now all of a sudden the word free will might be a word that we would use to explain why Mary did it. I would argue that though Mary, okay, I'm sorry, it sounds terrible, but I would argue that Mary, though she might not realize it, is in fact the product of laws just like the law of gravity, which govern her behavior. She's not aware of them because they're incredibly complicated, but that doesn't mean they don't exist, okay? My entire doctoral research was involved in trying to discover the mathematical laws to describe human decision-making. The laws which describe why a human being does one thing versus another thing, okay? I was working with pigeons for a while because the laws are the same across all animals. These laws are laws. I mean, gravity is gravity, whether you're talking about keys or dropping a Volvo. I don't know, I made that one up. A law is a law, okay? And so I would personally argue that there are laws that describe. Now, hey, I'm going to go back down to that bottom one, in fact, for a second. And that is to say that nature is understandable. And that is, I don't know, I mean, these laws are really complicated. I mean, they're really complicated. Just because I don't understand why Mary did what Mary did doesn't mean that there are not laws, that it is not possible to understand those laws. It's just those laws are too complicated for me at the moment, okay? If you look back, 100 years, I mean, we can say, why did so-and-so have a heart attack? And 100 years ago, I don't know, but today we do. Okay? In 100 years from now, maybe we'll know why Mary did those things. Maybe not. Okay? I would argue, though, that it was determined. Mary's behavior was determined before she was ever born. This is I hope that you're starting to realize that in a lot of ways, these assumptions of science sort of remove a need for God, don't they? Because everything is predetermined, or at best, we're going to come up to Newton's view of God. Newton's view of God was this, that God set up this planet, set it all up, and then hit the on button, and then step back. And God is omniscient, and you know why God is omniscient? God knows everything. The reason God knows everything is because it's already determined. The moment he hit the start button, God's job is done, he's out, or she is out, and the system just runs, okay? It's predetermined, and that's why God is omniscient. Okay? I don't know. It's kind of an odd thing, but that is the assumptions that science must make. All right. There are two competing views to science that are interesting. These are not psychology per se. These are science in general, but I want to point this one out first. This is Popper, Karl Popper. Karl Popper. Okay? Science is the unending search for better solutions, better answers. As I said, we are explanatory creatures. We want to explain things. The goal of science is to just get better and better and better at explaining things. Well, here's a very important thing that Karl Popper points out, and that is in science, you can never prove anything. Nothing gets proved, okay? He said that the best that you can do with a theory is say, well, it's not yet disproven, Okay, the highest, there you go, the highest status a theory contain is not yet disconfirmed. Okay, you can't prove anything. And so it goes like this. Okay, I can bounce a ball, and it hits the floor, and it bounces back. Well, it's Super Bowl. And I bounce the ball, and it hits the floor, and it comes back. And I bounce the ball, and it hits the floor, and it comes back. I've got a theory. My theory is that if I bounce the ball, it's going to come back. Now, I've made a million observations. A billion observations. My theory, I bounced the ball, it came back a billion times. Now, have I proved that if I bounce the ball, it won't go through the floor? No. But here's the deal. If I put the ball one time and it goes to the floor and it goes through, that one single observation disproved my theory about balls and bouncing back, right? I've disproved with one observation. But throughout billions of positive observations, I have proved nothing. It is one disconfirmation disproves a theory. And so the best status a theory can ever have is, well, we didn't disprove it yet. All right, that it hasn't yet. We haven't yet found the evidence to disprove it. And so, according to Karl Popper, it is just a search for a better and better explanation, one that is harder and harder and harder to disprove. Kuhn, on the other hand, argues for something called paradigms, and paradigms are kind of, you got to pull back that idea of zeitgeist that we talked about in the previous video. Remember, zeitgeist was sort of like spirit of the times. A paradigm is sort of like spirit of the times. A paradigm is like a way that everybody in the discipline tends to view a discipline. Okay, the simplest explanation, the one that works the easiest, the easiest isn't to you, but the one that works, okay, really? The one that works best is a recognition about, I'll come back with physics, okay? What happens is, in physics, there was a paradigm, Newtonian physics. What do you know, okay? And what happened is that everybody was thinking, all physicists thought in the way that Newton thought. They had the same assumptions that Newton had. But what happened was all kinds of wacky things were happening. And eventually there was enough wacky things happening that Einstein said, hey, you know what? This ain't right. There's something not wrong. Something not wrong. Something's wrong. And so Einstein made a radical shift. All right? And now Einsteinian physics is the way that the paradigm is. But again, all kinds of different wackiness is showing up with Einsteinian physics, and if you use the assumptions that Einstein had, then all kinds of wackiness. Now, there's perhaps, again, what do you know about physics, right? But within the realm of physics, it almost seems as though string theory may be the newer, the thinking of physics which will replace Einsteinian physics, okay? So a paradigm is sort of like a way of thinking that everybody in a discipline uses at a given time. And so, it's commonly shared. Most sciences, one viewpoint is commonly shared. A paradigm. Paradigm is the way, and according to Kuhn, by far the majority of science is what he called normal science, which is science which goes along with the current paradigm, and it's gradually building up different pieces of evidence, and what happens is normal science progresses, and it's not particularly interesting according to Kuhn. By far the majority of science according to Kuhn is not interesting. But what happens is normal science progresses, it tends to point out problems with the current paradigm. And as enough problems arise, eventually, bang, there's a shift. Okay, and so a paradigm shift, which is a word which has hit the common popular press, it does derive from this, a shift in the paradigm. And so what happens is, according to Kuhn, during science, the original pre-paradigmatic stage, there's a lot of different schools to explain a bunch of random stuff. There was a pre-paradigmatic stage in psychology for sure. Question is, have we ever gotten out of it? During paradigm whatever. The paradigm stage, there's going to be science going on. There's going to be a commonly held paradigm that everybody in the discipline is going to go with, and then eventually, as I said, enough counterfactual information or counterfactual evidence is going to arise that somebody will say, you know what, our basic assumptions probably aren't right. There's something not right here, and we're going to move along. We've seen this recently in the field of genetics with the rise of new epigenetic thinking. That was the most recent paradigm shift that I could be aware of. And so here's the words. As normal science progresses, anomalies arise. It can't be explained by the paradigm. Someone will propose a new paradigm, and bang. Okay? Eventually you'll shift. And it is these paradigm shifts that are important. It is not the progression of normal science. Okay? So the question that that comes up with Kuhn is, what is psychology? Okay? Is it a discipline without a paradigm? Or is it one with several coexisting paradigms? And I kind of believe, again, I'm biased, okay? But I believe that biology is the paradigm that we in psychology must follow. Is that ultimately all human beings are biological creatures. We are the product of the biology behind us. I know, nature, nurture, we'll have another conversation about it, but you are, whether you want to believe it or not, the product of not just the biology that mom and dad gave you, but the product of the biology that millions and billions of years of evolution have beaten into you. Okay? But that's for another class. That whole caveman talk. All right. Yeah. Determinism is, remember we had said one of the basic assumptions of science is determinism. From a very hard deterministic perspective, human beings are very mechanistic, that the laws of the physical world apply to human beings as well. In fact, we're going to talk about some of the early philosophers that had some really wacky beliefs about how ideas were physical entities, and therefore an idea, just like, say, for example, you can explain the movement of your arm using the laws of physics and levers and fulcrums and all that crap. They felt that ideas were physical products that could also be explained using the same types of laws. Okay, soft determinism says, look, I mean, granted, there are some laws out there, but there's things that intervene. I mean, things can modify. At some point, I'll have a discussion about the primary laws versus secondary laws, but that's for another story. Chaos theory says that systems are so complicated that even if determinism is true, it's going to look as though free will is present. All right? There's some truth to that now, isn't there? And then the last thing here is this question of universalism versus relativism. That is, universalism is this, the goal of science is to discover general laws and principles that govern the world. You need to discover these universal truths. And relativism is that universal truths don't exist, or if they do exist, you couldn't possibly know them. We're going to come back to this in one of the reaction papers, where I'm going to ask you this simple question. I don't think it was maybe reaction paper 5, but the question basically comes down to this. If you want to truly know another human being, is it better to know the universal laws, or is it better to know the things that make that person unique? Okay, which thing would make you know them better? But we'll come back to that one later. And so what I want to do now is that we've had this kind of talk about it. Let's talk about what is science, okay? Again, very briefly, I talked about this stuff in the separate video about reaction papers, but 3 pages, a title page and 2 pages. Take a look at the APA style. There is a separate video about APA style. I have a sample paper up about it, okay? In this paper, you got to do both facts and opinions, okay? As I said in that previous video, facts without opinions is boring as shit. Opinions without facts is just an opinionated blowhard. You're not allowed either one of those things. It's worth 30 points if you choose to write it. Remember, you got to write 5 of the 10 possible. This is the first one. Check out the syllabus for the due date. Call it history, and then put your last name, and then RP1, okay, for this one, RP1, and then go to Blackboard and turn it in the RP1 turn it in link, okay, in the assignments folder. So, going back, what is the paper going to be? Now, what does it mean when a field, such as psychology, is a science? What does it mean to be science? Well, does it mean that things are empirical? Yeah, maybe. In my mind, the answer to this question has to do with what is the data that is involved. And I mean, the data of psychology is, publicly observable. It is repeatable. It is, repeatable, publicly observable, and, falsifiable. No, what the hell is the other one? I can't even remember. But we have good hard scientific data, okay? Any good research must have quantitative numbers, okay? The problem is that in science, okay, in fact, here's I'm going to flash forward. I want to say this was basically Galileo, of all people. Galileo's argument, he did not like the concept of psychology as science. There was not even a psychology existing at the time, but he talked about it. And it goes like this. If a tree falls in the woods, does it make a sound? Okay? So now, given this little thought experiment, number one, if a tree falls in the woods, then in fact the tree does fall, okay? That this mass, which exists, does in fact fall. But does it make a sound? And according to many people, the answer is no, because sound only exists if there is a human ear for it to exist. And in fact, Galileo called these primary qualities versus secondary qualities. And he wasn't the only one, but he was the first. And this is a kind of an interesting idea that psychology is usually interested in studying the secondary qualities. The qualities that can only exist if a human being is there to see, hear, or taste them. Okay? But that tree, independent of human existence, if that tree falls in the woods, it does in fact fall. That's mass. Mass exists whether a human being is there to see it or not. Okay? I don't know. That's an interesting thought. Is psychology a science? Is psychology a science like physics and chemistry? Okay, that's we study secondary qualities. We study internal processes. But there's an awful lot of overlap, in particular when we get into things such as biological psychology, because all of a sudden we're talking about the biological correlates of mental activities, and the biological correlates have a physical existence. Yes, okay, what is the color red? Oh, I don't know. That is a secondary quality. But what are the brain changes that occur when you see red? Now, that has physical properties that are independent of an observer. Okay? What makes the science of psychology difficult? And the answer is very simple. Okay? Very simple, very complicated. In chemistry, okay, here's the deal. I can take 5 petri dishes and lay them out, okay? And I put in chemical A and chemical B. Lovely. Oh, look what happened. Then I take a second petri dish and I put in chemical A and chemical B. Guess what? I ought to get the exact same result. Now go to the third one. Chemical A, chemical B. Perfect. Got it. Now let's take a human being. Let's start with 5 human beings and let's do, experimental manipulation and measure them. And a second person, experimental manipulation, and measure them. Are you going to get the same result every time? Oh, hell no. Because human beings are not petri dishes, okay? And that's what makes the science of psychology so difficult, is that we don't have a petri dish to start with. Chemistry is a joke, man. Chemistry's so easy because they just start with a petri dish, throw in some chemicals, and you're going to get the same. As long as you have cleaned your petri dishes and you accurately measure out your chemicals, problem solved. With human beings, I would argue that the same laws that define the physical world are present. But human beings are so much more complicated than a petri dish that it is almost impossible to discover these laws, okay? That is my opinion. Human beings are not petri dishes, and that is what makes the science of psychology difficult. All right, so now, check out the syllabus for the due date on this thing, and I'll see you next time, and we'll move into Chapter 2 and start to talk about philosophy.